So when you want to grow a classification decision tree, an intuitive metric which comes to your mind is classification error rate. It is very similar to the actual minus predicted of the regression decision tree. Now what is classification error rate? It's just the proportion of observations which don't belong to the most common class. So in a particular region, if let's say 70% of an observation is belonging to the most commonly occurring class, so 30% becomes your classification error rate. Now why this can't be used to grow your decision tree? The reason being, it's not sensitive enough for making those binary splits, because if you remember your regression decision tree, we were using our actual minus predicted sum of squares that was branching our decision tree. And what was the predicted? It was mean of the training observations. But here the problem is we are having the prediction done on the most commonly occurring class, and based on that we have a classification error rate. And this is not sensitive enough, because if you look at this classification error rate, this only talks about the most common occurring class. It completely ignores the distribution which is apart from most common occurring. Now this is one way to think about it. There could be multiple computational reasons or mathematical reasons for it, which you could Google up on your own. But this idea is that this classification error rate is a natural thing which comes to mind when you transition from regression decision tree to classification decision tree. But this is not sensitive enough to make those binary splits. And that is why we use something known as entropy or Gini, which we'll talk about in a different video.